Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about Python for machine learning and data science, and in this tutorial we will study about generating descriptive statistics on the data frame. The Pandas data frame comes with a few useful functions to provide us with some detailed statistics about the values in the data frame. Okay, so this means that if we are looking to perform some statistical operations, so Pandas consist of predefined functions with the help of which we can see all these certain operations. For example, we can use a describe function or a method to get the values such as count, mean, standard deviation, minimum and the maximum values, and also we can find out the various quartiles. Now, as we are been knowing about the terms which I have already told about, that means count, mean, standard deviation, minimum, the maximum value. But if we talk about the quartiles, these are the values that divide the data into four quarters. Okay, that means into four parts. The data is divided actually into four segments. Okay, if we just consider that there is a straight line and all the values has been distributed on that particular straight line. Okay, so the quartiles will divide this straight line into four parts. Okay, and these are considered as four segments according to where the number falls on the number line. Okay, usually we can visualize the quartiles with the help of a box plot. The four quarters that divide a dataset into quartiles are as follows. The first quartile is the lowest 25% of numbers. What does this mean? See, as I have already told, that we are dividing the distribution into four parts or the four quarters. The mid of it is a median value. Okay, and the left of the median is the lowest distribution of the values, and at the right there will be highest distribution of the values. And in the lowest distribution also we are dividing into two parts. That means the first lowest and the second lowest. In the highest distribution again we are dividing into two parts. That means the second highest and the highest. Okay, so the first quartile means the lowest 25% of the values. Okay, that means the first quarter. Then the second quartile means the next lowest 25% of the numbers, that means up to median and above the first quartile. Okay, the third quartile means the second highest 25% of the numbers, that means above the median but below the highest quartile. Okay, and the fourth quartile is the highest 25% of the numbers. Okay, so this is how distribution is being done. Now, if we talk about the percentiles, 0th percentile means the smallest number in the group. Okay, so actually we are organizing the numbers in a form of a group, or we can say that we have arranged them in an ascending orders or descending order, whatever. Usually we are arranging the numbers in an ascending order. Okay, so the 0th percentile means the smallest number in the group. 25th percentile is the end of the first quartile. Okay, so where will be the end of the first quartile? That is the 25th percentile. 50th percentile is the end of the second quartile. Okay, the number at which the second quartile ends, that is the 50th percentile and its median. Okay, the 75th percentile is the end of the third quartile. Okay, and the 100th percentile is the largest number in the group. Okay, so this is how we classify the percentiles. Okay, so it's better to understand one example to understand the concept of quartiles. Okay, so how we can calculate the quartiles, let's understand. See, we have been given a data set like 22, 12, 14, 7, 18, 16, 11, 15 and 12. These are respectively the values. These are 9 values. We are required to calculate a quartile deviation. So how to solve this problem? first we reorganize these data in an ascending order to find Q3 and Q1. Okay. First we will calculate the Q1. That means we are looking forward to calculate the first quartile and the third quartile. Okay. So in order to calculate the first quartile, it can be done like this. Q1 equal to 1/4 9 plus 1. What does this 9 plus 1 means? 9, that is the number of the data. Okay, so it's actually a formula. 1/4, why we are taking it as? Because this is the first quartile. So it is 1/4 9 plus 1. So after getting the value of Q1, it's 2.5th term in this particular data. Okay, in this data, it's the 2.5th term which will be going to our first quartile. Okay, now if you talk about Q3, how we can calculate the Q3? So it will be 3/4 9 plus 1. Okay, obviously this is the 3/4. That means we are taking the third, so we are placing 3 here. Okay, so 3/4 9 plus 1. So it's about the 7.5th term here that will be going to be the third quartile. Now actually there doesn't exist any 2.5th term or 7.5th term, so we need to have some calculations. So in order to calculate Q1 and Q3, we need to apply certain formulas. See, Q1 is an average of the second, which is the 11. Okay, whose value is 11 here. Fine. Actually, we are getting Q1 as 2.5th term, but there is no exactly the 2.5th term. Okay, we are having the second term. Okay, so if we need to calculate the first quartile, we need to apply a formula such as we will add the difference between the third and the second term. Okay, and then we will multiply it with 0.5. Okay, so here the third term is 12 and the second term is 11. Okay, so the difference between third and the second is 12 minus 11, and we need to multiply it by 0.5 because we are here taking the term as 2.5, so we will taking the fractional part, that is the 0.5. Okay, so 12 minus 11 into 0.5, okay, that will be 0.5, and we need to add this thing with the second term value, that is 11. Okay, so the result will be 11.5. Similarly, if we need to calculate the third quartile, that means Q3, we are getting it as 7.5th term. There is no such term, so we will take the 7th term. So the 7th term here is 16. Then what we will do, we will take the difference of 8th and the 7th term, that is 18 minus 16, that is 2, and then we will multiply it with the fractional part of this term, that is the 0.5. Okay, so 18 minus 16 is 2, into 0.5 is 1, so the result is 16 plus 1 17. So Q1, that means the first quartile, is 11.50, and Q3, that is the second quartile, is 17. Now if you want to calculate the quartile deviation formula, so it's given as like this: Q3 minus Q1 by 2, that is 17 minus 11.50 by 2, so the result is 2.75. So this is how we calculate the quartiles. Now let's consider one example, okay, and then we will understand how Pandas has been used in the statistical operations. So here it is. Alright, so import Pandas as PD, import NumPy as NP, df, that is equal to pd.dataframe. Okay, so we are creating a data frame, and here we are taking the arguments as np.random.randn 10,4. That means we are creating a standard normal distribution where there will be 10 rows and 4 columns, a table, and that distribution values are filled in this table with the help of a random values. Okay, we are naming the columns as A, B, C, D. Okay, that means there are 4 columns. So we are taking one more argument here, and it's been naming the column values. Then we are printing df.describe. So here we are taking a method as describe, okay, to see all the statistical methods. Okay, so let's save this code and run this code. Alright, so here it is. So we can also perform one thing here. That means we can print the data frame also. So it can be done like this, print df. Okay, so let's save this code again and run this code. Here is our data frame. Okay, and then we have printed the description. So the first one is the count. Count means we are having obviously 10 values in each column. Okay, so the count is 10 for all. Mean. So here a mean has been calculated for each column. Okay, so that means 10 values. So the sum of all the values divided by 10. Similarly, we have calculated the standard deviation in the next. Okay, and then minimum. Okay, mi stands for the minimum. We have here mentioned the minimum value in this particular column. So the minimum value is minus 1.3 something. Okay, and then 25%, 50% and the 75%, these are what? These are quartiles. So this is the distribution, where is the 25% distribution lies, where is the 50% distribution lies, and where is the 75% distribution lies. That means 25% the lowest values, then 50% that is the to the next of the lowest value, that is up to the median, then 75% that is above the median. Okay, so that means the first quartile, the second quartile and the third quartile values. Then this is the max stands for the maximum value, okay, in this particular column. So I have already told how to calculate the quartiles, and these are respectively the notation, that is count, mean, standard, minimum, the maximum. This we already know how to calculate. Okay, so this is how we can show for the statistics in Pandas. Alright, let's proceed ahead. If we simply want to compute the mean in a data frame, that means no other description we need, so we can use the mean function, okay, indicating the axis. Okay, so let's consider one more code. Alright, so import pandas as pd, import numpy as np, and actually we are writing the same code as we did in the previous example. df equal to pd.dataframe np.random.rndn 10,4 columns equal to list a b c d. Okay, that means 10 rows and the 4 columns naming a b c and d with a standard normal distribution random values. Then we are printing this data frame, and then we are calculating the mean here, and we are giving 0 as an argument to the mean. That means this is the value of the axis, and the 0 means that we need to compute the mean for each columns. Okay, so let's save this code and run this code. Alright, so here it is. The mean for each column, that means the column A, column B, column C and column D is given respectively like this. Okay, now if we want to get the mean of each row, that means we can set the axis to 1. Okay, so let's again consider one code, and you will see how to calculate the mean for each row. Okay, so here it is. Again we are taking the same set of code, and we just did one change. That means instead of 0 we are giving 1 as an argument here in the mean method. Okay, so let's save this code and run this code. So here it is. Okay, so these are respectively the values for the mean for each row. Okay, so here we have calculated the mean of all these 4 values, then these 4 values, and so on till the row number 9. Okay, so here there are 10 rows, and we are calculating the mean for each row, and we are presenting it here. Okay, fine. Alright, so that's all for this tutorial. We will come up with more informative tutorials on Pandas. Thanks for watching. Kindly do subscribe to my channel.